So go ahead and open up Python. We are going to make a class that has just like 2 fields in it at the beginning. It's a bank account class or a customer class. Now don't write this, but I'm going to demonstrate how you do it in Java. Class, customer, like I said, don't write this. And then you list the fields of the class. I have somebody's name, and I have somebody's bank account balance, like that. And then you could add some methods to it. You could do, okay, I'm going to deposit something, and I want it to be able to take a number of the amount, like that, you know. And you can write your functions that are attached to that class so that you could call deposit and deposit money into that account, or you could call, you know, debit and withdraw that much money from the account. The syntax for it is, in that kind of language, is simpler than it is in Python, and I guess it's because maybe Python wasn't written to be object-oriented when the first iteration of it, you know, in the 90s, whereas Java was, since it was meant to be an improvement of C++, which is an object-oriented language. Object-oriented means that it uses classes so that you can create objects rather than just small pieces of data like ints and floats. Alrighty. You use the class keyword. Class customer. And the syntax for this is going to be totally alien. You saw that when you watched the video. You have to create what's known as a constructor. This language calls it the init function. The init function is what is called when you make a new turtle, a new customer, a new whatever this is going to be. So define, and these are double underscores when I do this. Underscore, underscore, init, underscore, underscore. The first thing that is passed into the init function is the object itself. And this is what makes this look considerably odder than it does in Java or C++, a lot of other languages. And then we're going to pass in the customer's name, and we're going to pass in their balance. And we're going to indent, so I forgot to put my colon there. When those values are passed in, we're going to say that the name of this customer is equal to the name that's passed in. So self.name is equal to name. Self.balance is equal to balance. That's really maybe enough to get rolling. Let's see what this does. Pardon me? Well, we're going to try to create a customer first. And then we're going to add a whole bunch more code. So anyways, C1 is equal to customer, and we have to pass in somebody's name, Fred Flintstone. And we have to pass in his balance. He's got $10,000, or rocks, or whatever they spend in Flintstone land, or whatever that's called, bedrock. Okay. Then we can make a second object. C2 is equal to customer Barney Rubble. Yeah, he spent all of his money gambling, so he's only got $500 left.
Corey's not paying what he used to.
Yeah. All right, let's save this and call it customer.py. Now this stuff down here, let's actually put it in one of those underscore thingies. So if underscore name is equal to quote main colon, then do these things. The reason we're doing that is so that we could import the customer class in another script. And then I'm just going to print a done message because this is really not doing anything that provides any output. Let's run it. Hope that I have no syntax errors. Okay, done.
Did that.
It did that. Okay. So we have the beginning framework. We have a class that's got two so-called member variables. The member variables are members of the class. We've got a name and a balance. So we could print out Fred's name or Barney's name, print c1.name, comma c2.name. We're just going to print their names out. Oh, bless you. And it worked. It printed out their names. We could do the same thing to print their balances. c1.balance, comma c2.balance. You know what, let's print tabs in between these things. Quote, backslash t, quote, comma, just to space them out a little. Let's see if that works. Nah, it didn't work. Oh well. Not going to take any time to fix that. Tell you what, let's print C1 name, tab C1 balance, and then print C2 name dot C2 dot name and C2 balance. That makes more sense. Still the spacing's wrong, but that whatever.
So C1's a customer object?
Yep, we have defined a customer object right there, and we've created two customers right there.
So does it have to say the word object in it?
We're calling them objects even though that's not a keyword.
Okay.
Conceptually, an object is an instance of a class.
I didn't know if it was purple because it was in the parentheses or because object is a keyword.
Oh, what do you know? That is there. Okay, that is a keyword. But that's used in the definition of it. We don't use the object word down here. There's some weirdness going on. Like when you create the object, you'll see two arguments here, but you'll see three parameters for the constructor. So all of our functions that we write are going to take a parameter called self that we don't pass in. It just creates it all by itself. So even if we have a function that doesn't take any data like this, we're still going to have to write a function that takes self up here. And I'll show you what I mean.
Is self like how it stores its variable name?
Yeah, it refers to this particular instance of the class. It's how it differentiates between the pieces of data in the class and stuff like local variables or parameters.
So self is C1, like the letters C1.
Right, or C2 or whichever. So
Okay.
let's write one called print info, something like that. So define print info. We don't even have to specify, which customer we're printing because that's being passed in as so-called self. And then we're just going to do the same kind of thing that we did down here. Print name equals, comma, self.name. Print balance equals, comma, self.balance. Get rid of those two print statements and let's just replace them with a call to c1.printinfo and c2.printinfo. c1.printinfo, c2.printinfo. There we go.
Neat.
So, I called them member variables, but you could also call them fields. That's also an acceptable term for them. I have to create them. I have to define them inside the init. So if I decide later on I want to add an address field, customer address, self.address is equal to, well, whoops, I'm not passing in an address. Do I modify the constructor so that it will take an address? I'm not going to do that at the moment. I'm just going to do not set. That means that when I call print info, I probably should print the address as well. When you move on and do some C++, C#, or Java, you will see the this keyword rather than the self keyword. Alrighty, now when we run, it's going to try to print the addresses, but we don't have any addresses. We haven't set them. Two things we could do. One is we could just set them right before we print them. C1.address is equal to, I don't remember the addresses in Bedrock, so I'm just going to make up stupid stuff. 2301 South Main, and C2's address is equal to 93 West East Street. Yeah, whatever. Okay. Now when we run it, we have some addresses to print out. And then this syntax can get horribly more complex at this point.
So why didn't we put address in the initial?
There was no reason not to. But at a certain point, you may get an object that is so complex that you don't want to have to pass in a million different things into the constructor. So let's go ahead and do that. Let's add comma address here. And we're going to do address is equal to address. You could give these different names if you wanted to, but it's best if you use the same names just because they're very clear. You know, there's no reason just to call that one in and say self.name is equal to in. All right, that's great, except it's going to blow up. Here we go. We have broken the existing code by changing the constructor. That's one reason for not adding stuff willy-nilly to the constructor in a production environment is you run the risk of breaking existing code. How do you fix that? Well, you could pass in an address like this, you know, 2301 South Main. That would fix it. Now this is the only one that's going to break. Another thing you could do is provide a default value. The way you provide a default value is you just do equals right there. And so even if an address isn't passed in, it still has something to fill in there, whatever the default is. I may even stick the word default there temporarily. Now we never see it say default, but if I comment out these C1 and C2 address lines, I should still see it say 2301 South Main, but the second Barney is going to say that his address is default because we didn't give it a value. There we go. So we gave this parameter of the constructor underscore 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 init underscore is equal to the constructor. And heck, we could make balance have a default as well too. If we don't pass any money, the balance is 0. So down here we can make another customer. C3 is equal to customer Pebbles. Pebbles doesn't have any money or an address. Poor girl. Now C3.printinfo, we will see that she has a balance of 0 and an address of default.
I have a question.
Mm-hmm.
On the terminal screen, can you create another object?
Yeah, you could have more than one turtle.
They just can't run at the same time, which is weird.
Okay, because I tried writing one in the command line and it threw an error.
Let's do that. Go to New File. We're going to make 4 turtles and stick them in a list.
Well, no. I mean, like, okay, so go back to your terminal that you have open after you run it.
Right? Okay. Import turtle.
No, not turtle, but whatever you named this one.
Oh, the customer. Okay. You have to do import customer.
Okay.
No module name customer. Mer. Okay, I'm surprised. All right. I'm going to go kill that turtle one. Let's instead write something over here. Import customer. Just make a new one. Wait, that's Notepad. That's not going to work. Import customer. C1 is equal to customer Bob. And then C1.print info. And save it into the same directory as your customer class. I'm going to call this test cust. Yeah, and it blows up. C1 is equal to customer dot customer. That's what you get when you import.
Does it have to be a capital C?
Yeah. Because you'd see on the other one, right?
Did I do capital C on the other one? Yes, I did. Okay, so just like the turtle, customer dot capital C customer. Tell me you're going to work. Yay! Okay. So this is a very common pattern. You know, you could define each class in its own file, just like turtle is in its own file, and then the math functions are in another file, and so on. And then you just import them as needed.
So if you do from customer import print info, it still won't run just print info. You have to put customer.customer or
Well, you could do this, but right now we really only have one thing that could be imported, which is that. So we could change this code to say from customer import customer. And then instead of saying C1 is equal to customer.customer, you just do that. That kind of tidies up the syntax a little bit.
can I see that?
Yep.
Is the first one the name of the file, and then the second one the name of the...
Of the class that's specified in it, correct.
Okay.
So this is from file name import class. Now in a lot of programming disciplines, it's traditional to capitalize the name of your classes. That came about after the invention of C++ and stuff like that, so a lot of C++ programmers don't do that, but Java programmers tend to just about universally to do that.
For some reason, mine's not running.
Alrighty, let's look. So here's what we've added. For those watching at home, we just added this function. It's actually called a method. Every function inside of a class definition is called a method. So a method is a function that's just attached to a class. We added a new method called deposit that accepts, you had to put that self there just to define it, and it accepts an amount. We add that amount to the balance, and then we print it out, deposited, how much was deposited, and we printed out the new balance. Then we went down here and we gave some money to Barney, C2.deposit.
Can you have the global balance? Because it didn't work.
Well, let me see why it didn't work. Let me try mine first and then I'll go over there. Oh, well, what do you know? There is no, what did I do wrong? Here's how I printed the balance up here. Here's how I printed it down here. So I should have done self.balance.
That self means. I see what you're saying.
So did you have to do self.amount too? Or
No, because amount is not one of the variables that's part of the class. These are the only class variables. Question?
Yeah, mine's still breaking.
All right. Instead of calling C1.printinfo, C2.printinfo, and C3.po, let's create an array, a list. I'm just going to call them custs. Forget it, I'm going to call it capital L. L is equal to square braces, and then L.append customer 1, L.append customer 2, L.append customer 3, And then let's write a for loop to print those guys out.
Can the pin take more than one parameter?
No, actually it can't.
I didn't know if you could just append them all.
Yeah, that would be nice. I think there's something we could do in order to kind of hack that to work, but
It'd be a loop.
Well, if you were doing that, you probably just want to add it all to the list itself.
something that would create the list on the fly. You could do this, L, maybe this would work, or you could just do L plus equals and then, you know, C1, comma, C2, comma, C3. That would add them all to the list. That works.
That's beautiful.
Now let's print them out. For every customer, for, no parentheses, wrong language, for C in L, print C. That will print out each customer in turn. And let's print a blank line. Make our output look prettier. So I had some calls to print info down here. I'm going to comment them out because, no, that's not good. I've goofed that up. I'm not calling print C. That's a little bit too Java-like. Instead, I need to call c1.printinfo. c1.printinfo. I just had to change that line. Sorry about that.
And is it just gonna print C1's info? Or?
I meant to do C. Let's see how many mistakes I can make in 1 minute. Here we go. Let's run it, make sure it works.
That's a true test.
Invalid syntax.
C in L, not
Yeah,
C.
that's supposed to be the little word IN. You know what, I did that, you know, at noon today. You'd think I'd learn. Okay, here we go.
L's not the
Do you have this part? If you're getting L is not defined, then you don't have that.
Yeah, I have it. It's just that I made all my appends L lowercase L.
Right.
And then, yeah,
Right,
L,
okay.
C, L.
Okay, so we did a deposit.
Sorry.
What's the other thing you do? Withdraw.
Somebody had to give party that $100.
So I'm going to tell you what I want the withdraw function to do. And then I want you to write it.
Okay.
Withdraw takes amount as a parameter, just like deposit did. Reduces self.balance by that much. And then lastly, heck, why not print a message? Print the same two kind of messages. Print what was withdrawn and the new balance. Just like this stuff. Just copy those and change a word or two. And then lastly, why not return our new balance? So return self.balance. Make that the last statement of your function. You could kind of just start off by grabbing those 4 lines, pasting them, and making changes. Because it's very similar, except it has a return statement at the bottom.
Would it throw an error if you put self in the parentheses twice?
At which point?
Like if you said def deposit parentheses self, comma amount, would that throw an error?
Yeah. Self gets filled in automatically, so if you put any other references to it except that first one, it's not going to like it.
Okay.
Because it would then become a parameter we had to somehow fill in down here.
Okay.
I'm kind of confused on why. Well,
Obviously, that's not going to work for me because I haven't implemented withdraw. But one of y'all may have. I'm going to wander around. So I'm going to do withdraw as well. Define withdraw self, comma, amount. And I'm just going to copy those statements and make a few changes. Copy, paste. This, instead of the balance going up, it needs to go down. And instead of saying deposited, we need to say withdrew. And lastly, although it doesn't really, we don't really say why, we're going to make this return self.balance. The reason is that down here, where we withdrew it, we could have done something like this. X is equal to withdraw, and then it would tell us the new balance right there. We could print out X and we'd find out how much money they had in their account.
Oh.
That'd be the only reason to stick a return statement like that in there. But as we've seen, there's a problem. This is letting them withdraw money they don't have. We have to decide whether we allow that or not, and all of a sudden we're going to decide no. We hate that idea so much that we're going to make the program crash if they try to do it.
Yes, let's do that.
So if amount is greater than balance.
Yep, exactly.
Yeah. Okay.
So here, before we do anything, if amount is greater than self.balance, we have a problem. And how we're going to handle it is we're going to throw, in this language it's called raise an error, raise an exception, which you could then handle with one of those try except blocks. So the syntax for that is raise runtime, capital R, lowercase t, error, capital E, and then withdraw larger than remaining balance.
You didn't get that much money, fool.
Yeah, I pity the fool. All right.
Yeah, I like that ATM.
Else we're going to do all the rest of this stuff. Now honestly, you don't even need the else, because once the error is raised, it's not going to do any of the rest anyways. It immediately jumps out of that code. But if you like, you know, the symmetry of seeing else and stuff like that, you could do it. Else colon, do these 4 things.
So, in all honesty, what would be the difference between doing that raise runtime error and then just printing out our own error message?
Printing out your own error message is great, but when you add this, give this code to somebody else, they may not care that you're printing out an error message.
Oh,
We're
okay.
returning a balance, which they could check to see if it was negative. Instead, we're forcing the other programmer to deal with the issue, to decide what they want to do.
Okay.
So that's why you make it throw an error. Just like when we were trying to do conversions or something and it wasn't a possible conversion, you know, it could have just returned 0 and printed an error. But if you didn't notice it printing in the error, then you might wind up using that 0.
And do we want it to return the balance?
Not
Even
if
it
this
does-
error is raised. This error is like a great big go-to, or it's its own return statement. It's like doing this. Once you see a raise statement, it leaves the function at that instant, so it's not going to do any of this stuff. That's why that else is not strictly necessary. I could have taken that out.
And it'd still do what? Okay.
Right.
I just didn't know if you wanted to still return the balance even if they try to withdraw.
It won't return it. It's going to interrupt it. It's going to blow up before it gets to pass anything back. Let's run it. And now we get our big red error. Runtime. The withdraw larger than the remaining balance. Now that looks nasty, you know, but it's good because once we hand this code off to another programmer, we're going to tell them, okay, you have to handle that somehow. And a way to handle that would be down here to enclose this in a try and in an accept. Let's do that. Give me the syntax for try and accept. Try colon, tab that over, and then accept. What's the syntax for that? Anything? Do we just do this? Print. I'm asking you because I honestly don't remember it. Print.
Print, not enough money.
Yeah, not enough
Funds.
money, funds.
And then
To
put
withdraw.
Your withdraw function or when you call it in the try.
Not enough funds.
And then we get, it found it. Good. Not enough funds to withdraw. We could have queried this exception that was raised to get the message out of it. And I honestly don't remember how to do that, so I'm not going to do it. Okay, we're going to do one more example of a class. Are we all done? Or do I need to pause? Okay.
Okay. Thank you again.
Oh, sure. So let's make a new class. Stored in a file called rect, R-E-C-T, not like I got so wrecked last night. Here we go. rect.py. Class rect with a capital R, colon. And I'm going to leave that other one kind of visible here just as a visual reminder. The first thing you have to do, and you always have to have this,
What about the object?
is the constructor. So the init.
So we don't need an object?
Oh yeah, you need that too. The other first thing you have to do. Okay, there we go. So define underscore underscore init underscore and underscore parentheses self comma x comma y. That's just going to stand for the height and the width. Colon. Self dot x is equal to x. Self dot y is equal to y. That's enough. It's only going to have two variables. I'm going to come down here and create one of those rectangles. So if underscore underscore name underscore underscore is equal, too many double things, underscore underscore main, colon, let's create a rectangle. Rect R1 is equal to new rect, parentheses 10 comma 20. And then let's print done, just so we know something happened.
Is it rect.r1?
I slipped into Java there. Get rid of that word rect in front of it. In this language, you don't define the variables before you use them. There you go. R1 is equal to new rect. Still a invalid syntax. R1 doesn't use the word new either. Geez. Okay. All right, that worked. I apologize for going into Java mode there. It's your fault. I blame you. You had some pluses in there that made me think Java. Okay. All righty. So that much works. Now let's write a getArea method. GetArea will calculate area and return it, and the area of a rectangle is equal to x times y. So define getArea underscore self. We're not passing in any other parameters, so we don't need to put anything else after the self parameter. Area is equal to x times y. Return area.
Would it be self.x and self.y?
It's absolutely would be. It would not work if I didn't put those in there. Thank you.
Okay, and then I have a question then.
Yeah.
Then why do we do self.x equals x if we're not just going to use?
You got to set these values. You have to define them. Without defining them in init, it has no.
Oh, okay.
That's just how you
I see.
list them.
Okay, I see
Right.
what you're saying.
Right.
Gotcha, never mind.
And then later on, whenever you want to use them, you have to prefix them like that. Okay, so here, let's do let's define one more function that returns information about it. So define getInfo. It has to take self. We're going to define a string that says it's a rectangle. X is equal to plus self.x, but I'm going to have to convert that to a string. String, there we go.
X is a string.
X is an integer, so I'm having to convert it to a string. And then I'm going to add on to that y is equal to plus str self.y. Then we're going to return that string. We're letting this rectangle describe itself and tell us its information, just kind of like printinfo did, except printinfo put it in the screen. This one just returns a string, and then the client code down here can do with whatever it wants to. So let's do that. Down here, we're going to do print r1.getInfo, parentheses, in parentheses, has an area of, comma, r1.get area.
It's done.
Alrighty. Astonishingly enough, that actually worked.
I didn't. Okay.
If it did work for you, create 2 more objects and then make a list and add them to it. List is equal to, r1, comma, r2, comma, r3. And then write a for loop that looks like this. For r in L colon print r.getInfo and then r.getArea. So you just need to make 2 more rectangles there, r2 and r3. Go ahead and give that a shot. So this is what I've added, 2 more rectangles. All 3 of them are being incorporated into the list. And the syntax is invalid.
Is it because of your parentheses? Or would that matter?
Yeah, I think it is.
I'm sure it is. Let's get rid of these parentheses and see if that helps. Yep. Alrighty. There you go.
Professor, I'm getting an error, but I'm not getting an error message.
Alrighty.
Could be indention.
Write a class named circle. Yeah, you can see where we're going with this. That has 1 variable in it, radius, and has a get area method and a get info method. Remember, methods are functions. Get area should return, well, the area of a circle is pi r squared. So 3.14159.
9265.
Yeah. Okay, and times the radius squared. So self.radius to the power of 2. And get info should return a string with some information about the circle, just like it did in this one. So that's a class. And you can guess what the next part's going to do. Write a main code that creates 3 circles of 3 different radiuses. Adds them to a list named, wow, let's just call it L.
I like list L.
And uses a for loop to print out get info and get area. On each item in the L list. That makes sense? We've done 2 examples of it. So if get info completely stymies you, because we really haven't done this kind of string manipulation before, just make it return the word circle. You know, but if you can make it say circle of radius followed by the number, please do that. All right, let's make a drop box.